Hi everyone, I am Dr. N. Sivakrishna, working as an assistant professor at VNR VJEC. Today I am going to talk about one of the advanced instrumentation technique, STM, which is part of Chemistry for Engineers course for BTech students. I have arranged my talk in following manner. Briefly, I will introduce the topic. After that, I will talk about various types of electron microscopes, and one has to know about the tunneling effect if at all you want to understand the STM. Then after that, working principle of STM will be explained, and there are various modes to record the data on STM. Those things will be discussed, and finally I will explain the applications of STM. Scanning tunneling electron microscopy, which is actually a probe microscope generally used for imaging of surfaces of various nanomaterials in atomic levels. Here we can see the exact image of the STM, the instrument, how it looks, we can visualize here. Here the data also collected on this instrument, which is actually the data which depict the nanomaterial which is in the alloy form, that is silver copper alloy. So we can see the atomic level information of the this particular material. So if you ask me the types of electron microscope, there are two types of electron microscope based on the electron behavior. Generally, electron can show the dual nature, dual behavior, that is particle as well as wave nature. Based on the particle nature, scanning electron microscopy was developed, and based on the wave nature, scanning tunneling microscope was developed. So if you ask me how SCM works, same, that is scanning electron microscope works, it actually, the focused electron beam is used to capture the surface information of the nanomaterials. The resolution whatever you get in this instrument is 1 to 10 nanometers. The theory involved in this instrument is classical mechanics. What we get information is the topographic information of the nanomaterials, the surface of the nanomaterials, the composition and morphology of the nanomaterial surface can be captured. In case of STM, the quantum tunneling current is generally measured to map the surface information of the nanomaterials. The resolution will be quite high compared to the SCM, that is 0.1 nanometer resolution you will get it. The theory involved in this instrument is quantum mechanics. Basically, the wave behavior will be utilized to capture the image of the nanomaterials. The information what we get from the surface of the nanomaterials here is the topographic information as well as the electronic structures, that is the deepest information also we can capture on STM. What is tunneling effect? Generally, the tunneling effect can be explained based on the quantum mechanics. So what we know about the electron is, electron can show the dual behavior, that is particle as well as wave behavior. The particle behavior, if you consider it, it comes under classical mechanics. According to the classical mechanics, the particle will, if at all, is having the lower energy than the potential energy barrier which we are seeing here, then what happens is the particle cannot cross over the barrier. Instead of that, it will bounce back. But if you consider the quantum mechanics, the electron will be considered as a wave because of the wave which can actually have the oscillating properties which cannot cross the barrier, but it can tunnel through the barrier. That we can visualize here. So here whatever you are seeing the animation, so here the image of the dog is captured basically based on the particle behavior of the electron in case of SCM. So I will extend the how STM works based on the quantum mechanics. Here, as I mentioned, if the electron considered as a particle, that comes under the classical physics, where it cannot cross the potential energy barrier because the electron is having lower energy than the potential energy barrier, then it will bounce back. But in case of quantum physics, the electron behaving like a wave, because of that, it cannot cross the barrier, but it can tunnel through the barrier. How we can connect this particular concept to the STM? So in STM, the sample, generally the sample should have the conducting properties. So the electrons which are in the sample should migrate to the should tunnel to the tip. Here the tip also made up of with the metals like tungsten or iridium or platinum, which also shows the conducting behavior. So now the space between the sample and tip generally placed in the order of 0.3 nanometer to 0.6 nanometer. So that is almost in the order of 3 atoms distance. So the distance between the tip and the sample will be in the 3 order of the distance. So how do you explain the tunneling effect here? So the electrons are in the sample as well as in the tip. So now if they are in the vicinity of 0.3 nanometer angstroms, then electron has to cross the barrier, which is vacant space, which is there between the tip and sample. That will happen if you consider the quantum physics. So if the electron behaves like a wave, then it can pass through the vacant space which is generated between the tip and sample. So that information, if you can gather, then the image will be looking like this. So this particular concept is utilized to develop the scanning tunneling electron microscope. So let us see the working principle of the STM. So I am showing you here the picture whichever depicted here, the inner parts of the STM. The major part you see here is tip, which is actually made up of with the metal because it has to show the conducting property. The tip is made up of with the tungsten or platinum or iridium kind of metals, which is connected with the piezoelectric tube. The piezoelectric tube also consists of electrodes, which is actually this particular tube. What it does is it regulates the tip position on sample. So now this piezoelectric tube is connected to the particular unit, that is scanning unit or distance control unit. So which is further connected to the display, which is like monitor. And there is another unit in this instrument, that is amplifier. What amplifier does is whatever current which is generated through the tunneling process will be reached to this amplifier. What amplifier does is that amplify the information whatever is generated, whatever the tunneling current is generated between the tip and sample. So that information if you can map, then what you get here is the image will be like this. So wherever hump is there, the tunneling current will be high. Because of that, it will show the high current profile. Wherever the depth is there on the sample, that will show the low current. So here the animation also you can see how electrons are tunneling from the sample to the tip. So wherever the hump is there the current flow will be high. Wherever the depth is there, the current flow will be low. So that information will be gathered by the STM to map the surface information in atomic level. So the data can be collected in two modes. One is constant height mode and another one is constant current mode. In case of constant height mode, what we do is we place the tip and sample with the particular distance. So we monitor the current. Wherever hump is there, the current flow will be high because the distance between the tip and sample is narrowed. So now the current flow will be high, then that current can be visualized on the screen. So wherever depth is there, definitely the current flow will be low. So there is another mode to collect the information where you can fix the constant current. So now you will be allowing the tip to move from the sample according to the current. So wherever hump is there, so that the tip will be adjusting the height to maintain the constant current, whatever you have given the command. So the height can be monitored, so that will be displayed like this. So the entire information, whatever you see for the surface information, will be coming finally like this. So let us know the applications of STM. As I said, the atomic level information of the nanomaterials can be captured by STM. Even on the metal surfaces, semiconducting material surfaces, information can be gathered on the STM. STM also can be used to probe the local density of the electronic states, and we can also do nanofabrication, like writing some information, the structural information on the nanoscale also possible. And surface chemistry also you can do it. That means some catalytic reaction, whatever is takes place, can be monitored by STM. Even magnetic imaging is possible with the STM, where we can develop the, with this information, we can develop the sprintonic devices also. So these STM can be extended to the biological studies also, like imaging large biomolecules surface information we can gather, like DNA, protein surface information can be gathered by STM. So the entire presentation, I have collected the information from these references. If whoever is interested, they can follow it. And I have generated the AI based images. Here the BTech students are visualizing the surface of the nanomaterial by this particular STM instrument. So you can also see the VNR VJIT on the surface. So I would like to thank you everyone for your attention. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.